the slides. There you go. Perfect. Awesome. Thank you. Thanks, Matt. That was a very interesting presentation. We seem to be doing a hell of a lot of things very, very similarly. I will make sure to catch up with you because maybe we have a few things to share. But hopefully right now I can also show you a few different things that I so far have not seen, which is basically being able to create a radio station that that works as you expect. Previously, I've written an article about, a very, very quick article about this on my blog. And this is basically just a presentation format of that particular thing. This is called end-to-end testing radio pipelines. And hopefully I will be able to control things. Maybe not. Can I get the controls, please? Anyway, should have it. 1 sec. Thank you. Okay, there we go. So yeah, so this is going to be end-to-end testing radio pipelines, and this talk is about why testing radio audio output retroactively beats inspecting just events and things like that. And before we move on, I would like you to think through the following. So basically, imagine that you're listening to your favorite radio show. The DJ basically comes on, and for half a second, you hear the song that was playing before. That just sort of like bleeds back in. You'd be like, okay, that's weird. And then basically whatever you do, it's like you just basically move on. But there is a problem with that, which is basically the station itself doesn't necessarily have any idea what happened. So what that means, every single that it has says everything is fine. We usually have some monitoring, observability, and sort of different kind of events and those kind of things in place. But even if every metric was green, the now playing metadata was correct, the station has no way to know what you just heard. And that, I think, is a problem on its own, because you probably want to capture these kind of potential problems prior to actually going live. That is the particular gap between what the station sort of instruments see and then what the end users, the actual listeners see. And that's basically the whole talk. Okay. Hopefully that kind of makes sense. A little bit background so that you understand why I'm keen on these kind of things. My name is Attila. I am based in Budapest. I've been working 20 years writing reliable software, and I'm a TDD enthusiast, which basically means I test everything thoroughly as much as I can, or with as much as it's actually reasonable. And outside-in testing is the default for the web world, which is partially the industry that I'm coming from. I've also built a home lab radio station with Liquidsoap, Icecast, and Go. You will see in the next slides how it's actually being built and why this is interesting to me. And yeah, so basically that's the kind of situation I've had. I thought I had tests, and the tests were all green, but still there were a little bit of a problem. Let's see what that one was. But before we jump in that, it probably makes sense to actually explain to you how my system looks like. I'm assuming it's not that different from the rest of the stacks. Maybe a few different things are worth mentioning. The system basically is composed of two main areas. On the left, you can see things that basically produce the sound, which could be the harbor, the DJ streaming in, or even a scheduler queuing the tracks I'm at, and a folder full of music as a last resort. Basically, if something goes wrong, there's always got to be a fallback, of course. Basically, Liquidsoap picks just one, does the audio polish, normalizes, compresses, and whatnot, deals with crossfading and limiters and blah, 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 all that jazz, whatever you actually put it on. And it basically, at the end of the day, pushes it out as gas. It's fairly standard. It's just same kind of thing all over again. I'm pretty sure 99.999% of the cases are stations are sort of built like that. So that's the audio path. And then there's the second path running alongside it, which is probably a little bit lesser used or lesser known. Every time something interesting happens, for example, when a track changes, a DJ connects or DJ disconnects or whatnot, Liquidsoap fires a small HTTP post. That's the webhook. And so I have a little Go service that in the middle between a message bus and Liquidsoap, which basically just captures that sort of requests. That's the one that is actually called the sidecar here. Hopefully, you can see where I'm pointing. So that's the sidecar, and the sidecar is responsible for just doing the plumbing between NATs, which is basically a message bus, which essentially just turns different kind of events into interesting metadata that other services such as analytics or even the scheduler itself picks up, so that the different kind of microservices know and can subscribe to the different kind of events that they're interested in order to sort of guarantee proper operation. So again, just to wrap up, the system is basically composed in two different areas, the audio plane and the control plane. The audio plane is basically whatever the audio happens, and the control plane is basically everything that glues the systems together, or even the web UI and whatnot. Okay, hopefully that makes sense. So that's how the whole thing goes. So the intended behavior, as I mentioned, is very, very simple. Humans always beat robots. I'm very much hoping that this particular talk is not going to be processed by Claude or OpenAI or whoever in the future, because if it does, then I'm in big trouble. But that's a story for the future. Long story short, the highest priority ready source wins most of the time. What that means in practice is that the DJ takes priority when someone goes live. We want to even preempt the currently running scheduled track mid-track, because otherwise things could get very, very nasty with sticking to a original radio schedule and whatnot. And as things go further down, even if a scheduled queue becomes empty for whatever reason, remember, these kind of things are actually sitting in microservices, and every single one of the service is responsible for its own behavior, and thus essentially it could be thought of as a distributed system, which basically means that we do need error handling and fallback mechanisms in place. So yeah, that's basically, again, very, very standard. And here's the interesting thing. I have had tests for the different kind of events. If you go back here, if you take a look at it, we have had events when the DJ was actually joining, or when the DJ was ending the session, or when the scheduled queue changed everything. Everything was basically tested, but it was tested on the metadata and the events side, which basically belongs to the control side of things, not at the overall audio. And then, of course, as it happens, there's no bugless system. Sometimes the priority chain could not have been decided. What does that mean? It basically means that this is where a bug basically surfaced, but we were not aware of it only once the bug surfaced at the live production radio. So basically, Liquidsoap, whoever doesn't necessarily know, although I doubt that there might be a lot of people like that, but just for good measure, Liquidsoap holds a small buffer of the incoming DJ audio, and so in case of network hiccups, or can briefly empty the buffer. And when that sort of empty happens, the priority chain reads this as the DJ was actually gone. And that basically then schedules back to the, falls back to the scheduled queue that sits underneath in the next one in priority. For what that means is that for a fraction of a second later, the buffer then refills and the chain switches back. So what you can see here is that there's going to be flapping, which is basically the term used in the network industry. Flapping happens in between the different kind of sources. What that means is that it becomes very, very annoying, and sometimes the scheduled track sort of bleeds into the live audio. So that's what we have had there. We have fixed it. The actual fix itself is not that big, not that much of a big deal. It was actually introduced, sort of fixed by some smarter buffering. But the point that I'm trying to make here is that we thought we fixed everything, but then it turns out we did not. And there is a very, very good reason for that. It turns out at the end of the day, we were not fixing the things where we wanted to. We didn't fix the system as overall. And part of the reason that is we haven't actually measured how things were working. And part of the reason is, long story short, even if you fix issues in smaller components of your systems, your tests were basically green, but you don't necessarily know what actually happens on the actual very end, which is basically what the the listeners can hear. The other thing is regressions are potentially silent. If you were to make a change to your Liquidsoap configuration without having proper tests in place, which basically exercise the entire stack, including the different sort of inputs and whatnot, you will not necessarily be able to catch the regressions. And so that is a very interesting thing because it ties back to whatever I'm actually coming from, which is basically the web type of way of thinking about it, which is basically outside-in testing, which is basically the point that I'm trying to make here. Again, just for a quick measure, for the good measure, we've tried in the first attempt test the control plane, which basically means that there was a fallback playlist placed on startup. We have taken a look at the webhook logs. When the icecast metadata matches the webhook, we did look at webhook logs. And again, as you can probably imagine, when the telnet queue push happened, what did we do? Of course, we looked at the webhook log. Everything in terms of the events, they seem to be normal. They seem to sort of like match and make sense. However, that was not necessarily good. Even if the test suite ran on the CI server on every push, everything was green every time, but the problem was still there, and we had no idea why that happened. So I was like, okay, let's think about this. What is testing anyway? Testing is effectively the observing what we expect. And if you think through this, you don't expect necessarily just events to appear in the good order in your system. If you do care about your listeners, that's where you want to test the whole thing. And it's not as obvious as you might think, but also it's not, it turns out it's not actually that difficult. So if anything between the input and the output breaks, the expected observation doesn't appear. Why? Because you are testing things in isolation. Testing your components are important when you're trying to test very, very high complexity and treat them as a unit test. But at the end of the day, you probably want to do something along the lines of like a proper outside-in testing so that you can measure what is actually going to go out to your listeners. So let's take a look at what does that mean. In case of web, if someone is coming from the web developer background, what happens here is that in web applications, you can test certain things in different kind of layers. You are likely going to test the database queries, different kind of HTTP controllers, request and response cycles. But even if those kind of things seem to be normal, web apps are basically run within the browser. So in the browser, if something goes wrong with the DOM, doesn't make sense, JavaScript weirdness, whatever happens, you will not necessarily know unless you actually try to simulate real behavior at the most outer layer of your infrastructure. In the case of web events, you would actually simulate clicks by the user and expect to see what normal behavior would give you. For example, in cases of placing an order, you would want to see a visual representation, a response, which basically just says the order was confirmed. The same sort of philosophy, this is the same kind of shape you would want to do in the radio. You probably want to play the scheduled radio, but at the end of the day, you want to hear whatever is actually on air is what you intended to run on air. Just some very, very simple examples. End-to-end testing in the wild. Like I said, you could use page go to URL, click on the buy, and then expect that the order confirmed text appears. This is interesting because every single layer of the stack is basically exercised, and they are not exercised or is being mocked outside. But once your tests do confirm this, you have a much higher level of confidence in your system as a whole, rather than just knowing that every single one of your components behave the way they do. Same kind of thing happens with mobile UIs or even video players. You could actually capture different kind of frames on the screen and assert whether the frames that you decode clearly do make sense and they're synced with the between the audio and the video. So hopefully it kind of makes sense what I'm trying to say here. And then now let's see how that one translates into radio. End-to-end testing applied to radio is not in any way different from these kind of things. The browser, which is basically in the web way, becomes the icecast stream because that's the very last spot where things where people start listening to. If I wanted, I could be a little bit picky and I would say like, okay, if I wanted to, I would probably actually drive the browser and see if the actual audio output that actually is leaving the Icecast stream can then be decoded within the browser or within a mobile app. But let's not get there because that's going to be a little bit too extreme. So again, in the case of radio, the browser becomes the Icecast stream and the DOM is the recorded audio. Basically, the DOM itself is whatever you are actually trying to test. The goal and the basic philosophy here is that you don't peek inside the system, but you test what the listener actually hears, okay? And that's the whole point, not trying to test the internal components, but actually the output. In our case, this is a very, very simple stack, nothing fancy. An Icecast, real Icecast server, real Liquidsoap Docker image with real radio Liquidsoap file. The sidecar container was actually a real Go service, and everything is basically real. The point here is that you do not mock things out, but you actually test system as a whole. And that's basically the whole thing. That's the real broadcast lifecycle. The great thing about this is that nothing is fake. Everything can run in roughly 3 minutes per CI run, which is a great way to actually test your changes before you deploy something to production and start playing, I don't know, death metal at 7 a.m. in the morning, just making sure, I don't know, whatever. But the whole thing is that the way you actually test this is one continuous broadcast. So how does this work? You basically start exercising your system. You start the live stream. For our case, we've played 10 seconds of a fallback playlist, which is basically the whatever the scheduler gives us. In the audio side of things, we want to actually find a track in the control plane, which is again how we exercise testing of events. We're looking for events. And as you can see, things kind of make sense when it comes down to how we were testing. The scheduler queue was tested for another couple of seconds. We then checked that the audio that we expect is actually coming out, and the metadata and so forth. Hopefully this kind of makes sense. The core idea here is that the real broadcast lifecycle compressed in roughly 85 seconds is being tested as the station starts up, the scheduler queues a track, the DJ connects and whatnot, and everything is basically done as all assertions are run retroactively against a WAV file recording. One of the main sort of like rules of testing is you are actually setting up the state of a system. Then once you have a very reliable state of the system and being able to exercise the behavior becomes a lot easier because by ultimately being taking under control what the system data is, it becomes a lot easier to actually exercise this on the outside. In our cases, we have had some very sort of like basic tests that we wanted to just double check. Was the DJ audible? What does that mean? It means that could you actually hear the DJ on time? Was did the scheduled track leak into the audio, or was there any sort of dead air? Obviously, you can start testing multiple different kind of or other things by asking more different questions. But the goal here is that the scheduled tracks themselves, yeah, did I swear? That's another one. I love that, by the way. The scheduled tracks are acting as test fixtures. What does that mean? It basically means that they are known inputs we can rely on, and each fixture getting a pure sine tone as its signature allows us to be able to match using those kind of audio signals at the very end. For this, I have used 3 FFmpeg primitives. Atrim basically carves a time window within the actual recording. Bandpass then allows me to sort of like isolate one of the frequencies. It acts as a little bit like a prism, if you think about that. And then there's silence detect that is also built into FFmpeg, which I was using to log every quiet stretch. So the question of was the DJ audible becomes a lot easier if you think through this way. Any silence range, by being used by band passing on the actual frequency that I'm supposed to hear, means a dropout from the DJ's perspective. And of course, we want 0 dropouts like that. The basic idea here is that by ultimately creating different kind of chunks and using bandpass filters, things get a little bit easier. Why? Just because our fixtures are actually very easy to be identified. The other question is, did the schedule track leak when it shouldn't? Which is, if you remember, that was one of the problems that we have seen. Becomes somewhat similar. FFmpeg ships with a silence detector, but not a presence detector. So what does that mean? It basically means that if you treat silences as the opposite in case of bandpassing, then suddenly you have an answer to like, hey, I know if those two things are being fed into the system and silences appear, by actually filtering out the negatives, it basically means you get to ask certain things like, when was, I don't know, this particular frequency quiet? And then you basically flip the switch and then you get an answer to those kind of things. This is a very, very easy and neat way of saying like, oh, I know that this kind of thing is right now on air. So basically, negation can also be used as a means to detect different kind of leaks and whatnot. Hopefully they kind of make sense. At the end of the day, I've decided to use 3 probes, 3 test frequencies, 550, 660, and 770 hertz. And as you can see, the scheduled one was 550, the DJ was 660, and then there was a weird test failure. So I was like, holy guacamole, that doesn't kind of make sense. And the tests did fail. So my automated test is failed. So like, okay, that doesn't make sense. Surely things are supposed to work out. Of course, I didn't take into account that the crossfades were in place. And in this particular case, when the crossfades happen, then there's some sort of like weirdness, which basically is I think it's called the God, I forgot. Anyway, what I'm trying to say here is that at this point, the compressor creates phantom frequencies throughout the fading, crossfade periods, and essentially results in unreliable frequencies, which then be matched. Yes, intermodulation. Thank you so much. That's the terminology I was looking for, which basically fails your tests. But nothing is wrong with your systems. It's just basically that the test reports a leak, which is at the end of the day the false positive. So there's obviously a fix to that. You need to make sure that your test signal is good enough and understand that the test signal is part of the system, which basically means if you do have intermodulation, then suddenly new frequencies can appear within your system itself, integer ratios, multiplications, and whatnot. So the idea here is that you want to be able to use frequencies that are very much outside, and instead of using 550, 660, and so forth, I decided to actually use very, very distinct frequencies, so that even with harmonics and compression, you would not necessarily have this particular problem. And I think that's pretty much it, because we're going to be running out of time. But the take homes here are the following: the test, you want to test the outside of the systems. Webhooks are not there, of course. You record once and analyze many, many times. Crossfade, silencing, ducking, same primitives, as you can probably understand with those 3 kind of functions within FFmpeg. Presence detection, absence detection, and silence detection. You could do a lot of different kind of things in order to be able to match every single one of the cases, even the exotic ones. And yeah, just keep it in mind that if what matters is what the listener hears, and that's what the test has to listen to. Most importantly, I'm not suggesting that this one replaces monitoring or observability, because that is a completely different problem, different tools, and a different set of potential errors and responsibilities. So yeah, continue to write unit tests for your services, for a scheduler, for whatnot, but then try to at least cover the heavy paths. That's what I'm saying. Thank you.
Yeah, thank you so much for that. I want to add something, that testing has been so, as you grow as an engineer, like I've just do tests. We have such a big test suite in Liquidsoap now, and it drives every rewrite to make sure we don't break. But I want to say something. In 2.5, I started adding, because I was debugging a pop in Crossfade forever, and it was the old ear stuff, and it was just not really working well. So I've added a layer now in 2.5 where you should be able to do frame hash extraction. And what I mean by that is that now you have a method, a callback, I think that's called onFrame checksum. And that callback should actually give you like a checksum of every single frame that comes through the source that you can output as text. And so it will generate a text file that is basically, it might not be what you want because it's 0.02 second per frame, but it will give you like a dump in hash of every audio that's created. That could be a stable basis for your test. Yeah, very impressive presentation, by the way. Thank you so much. Is there, I wanted to know, yeah, is there any question for Attila?
Thank you, by the way.
Yeah, well, you kind of answered that question, but I was wondering, you went for FFmpeg, which is quite a good choice, I guess, for the testing and not monitoring. So my question kind of stands, like, why couldn't you use a Liquidsoap client there?
It's very, very simple, you know. I needed to generate audio with pure sine waves, and for that I used FFmpeg. And then I realized, okay, FFmpeg is already in place in my stack. I may as well use it. That's part of the reason. The other reason is that I operate the system very much like a well, it's not just very much, it's actually a microservice architecture. FFmpeg itself doesn't necessarily have to be part of the same sort of component and the same service that is operating or running Liquidsoap itself. FFmpeg here acts as basically the orchestrator layer for the test environment and the fixtures, as well as a main part of the test suite. Now, needless to say, these kind of things don't necessarily go into production. In fact, these services are not deployed to production. They're only part of the CI environment that basically exercises your test prior to making a change to your radio infrastructure. So long story short, one, I needed it because I needed to generate the audio fixtures. And for that, I thought this was probably the easiest thing to do. And you can just very, very easily shout out to FFmpeg and just kind of works. But I would be intrigued to know how you would approach this using Liquidsoap itself. I'm open to any kind of suggestions.
Yeah, well, the thing is, I can't tell like how I would do it, because my point of view is more monitoring. It's not actual testing, so it will kind of get in your way if I was there. But still, like, if you wanted to just generate whatever sound you want on frequencies you want, like Sine does a nice job. And of course, you could just use FFmpeg inside Lick, and it's just so that you have all the tooling that's ready for starting the thing. Well, you can do most of what you can do in Lick in FFmpeg anyway. But like, I guess, of course, if you're trying to itself, maybe you don't want to use Liquidsoap for that, but kind of it's still kind of elegant. But most of what you do, I would do in Lick, but at the same time, I would not actually consider it testing. So maybe it's better you do the way you do it.
I don't know. It's actually a very interesting way, but I'll see how the two different kind of things compare. Thanks for the heads up.
One thing that I've seen in other frameworks like FFmpeg as a problem with that is that when you start using your own framework for testing, you put yourself at risk of self-referential test, meaning that if there's a bug, like if you test your encoder with your decoder and they both accept the same weird bugs, then you're not testing. So using a third-party tools is very valuable for that, in my opinion.